So in this video series, we're going to be running through a series of short lessons, which ideally will be covering every main topic within HSC Advanced Maths. So this will be from the beginning of Year 11 through to the end of Year 12. So let's get started. First, we're going to have a look at like terms. We're going to have a look at like terms, and we'll do a few examples of these as well. Now, all of these lessons are based on the current iteration of the HSC Advanced Maths curriculum. The structuring of this course is based on a series of different books and my own expertise and knowledge. So we'll talk about like terms. In algebra, we usually have what are called expressions. And an expression is a collection of numbers and letters. So you might have something like 3x, or you might have something like 4x squared y squared, or you might have something more complicated like 3 halves x squared y cubed z all to the 1/2. These are all expressions. And an expression really has two distinct parts. It has a bit at the front, which usually takes the form of a number. So let me just color the number bit in. Let me change the size of my coloring tool here. So we have a number bit like a 3 or a 4 or a 3 on 2, something like that. And then we also have another bit, which usually just consists of letters or pronumerals. Now, the pronumerals might have some powers above them or something like that, but that's okay. When we have expressions, expressions are either like or they are non-like. Now, the definition like, we're going to give it a very vague definition. We're going to say it has the same stuff at the end, bracket, when simplified. So if we take two expressions, let's say we take 3x squared and 3xy, the stuff at the end is the collection of all the pronumeral terms. So this is x squared, this is xy. These are not the same. Now, if these are not the same, then these two terms are not like terms. They're not the same, so therefore not like terms. If they are the same, then they are like terms. So if we take a different example, we might have, let's say, 4xx and 10x cubed divided by x. Well, if we look at these two expressions, we need to simplify them. So x times x is x squared. So this one is 4x squared. We have x cubed on top, x on the bottom. This x cancels. One of these three cancels. So we have 4x squared and 10x squared. The collection of stuff at the end of each of them is the same. So these are like terms. Collection of algebraic pronumerals is the same. So therefore, these are like terms. Now, in standard algebra, you can add and subtract like terms. And that's what we're going to be doing. Whenever you have a collection of terms, the like terms you want to group together. But if you have terms which are not like terms, you want to keep them separate. So you'll have like terms, you'll put them all together. The ones that are not like, you'll keep them separate. So let's have a look at some examples, and then we'll do some questions at the end. And you can pause the video and attempt the questions, and then I'll go through each answer. So for example, example 1, we have minus 2a plus 3b plus 5a minus 2b. Well, in these four terms, 2a and 5a are like terms because the stuff at the end is the same. This has an a, this has an a. 3b and minus 2b are like terms because the stuff at the end of these is the same. So if we simplify this, we have minus 2a plus 5a. That will be minus 2 plus 5 is 3a. And then we have plus 3b minus 2b. Plus 3 minus 2 is 1, so that's 1b. This can also be written as 3a plus b. So this is how we group like terms. We identify them by simplifying the algebra stuff at the end. If they're like terms, we can add them together. If they're not like terms, we have to leave them separate. So I'll put up a series of examples here that you can try. Pause the video, attempt them. Once you've attempted them, then we'll start going through them. So question 1 is going to be 2a plus 3b minus 4a. Question 2 is going to be 2ab minus 2b squared plus 7ba minus 4b cubed on b. And then question 3 is going to be, we might do 10z cubed minus 2y squared plus 4x squared minus 2z squared times 3z. So pause the video now, have a go. All right, so now that you've done that, let's go through some of the solutions. So we need to look for like terms. If there are like terms, we can group them together. If there are not, we can't. So for question 1, we have a 2a and a minus 4a. The b, however, is on its own. So we've got 2a minus 4a plus 2 minus 4, that's minus 2a. The 3b gets left on its own. So we end up with minus 2a plus 3b. Now for the second question here, we have, to be a little more careful, we have 2ab, 2b minus 2b squared, then we have 7ba. Well, actually 7ba is the same as 7ab. If you have algebra prenumerals and they're all bunched together, you're allowed to swap their order. So this and this are like terms. We have a minus 2b squared, and then we have a minus 4b cubed on b. But we know b cubed on b cancels the b down the bottom, cancels one of these. So this is actually a b squared as well. So we have 2ab plus 7ab, that's 9ab. We have minus 2b squared minus 4b squared, that's minus 6b squared. And this is the solution to question 2. Now for question 3, it's a little messier. 3 of the values, the 10z cubed, so we have a 10z cubed, we have a minus 2y squared, and we have a plus 4z x squared. All of these are different, so they can't be combined. But we have this term at the end, minus 2z squared times 3z. Now, from your studies in math so far, you can simplify this. Minus 2 times 3 is minus 6. Z squared is z times another z, that's 3z's, that's z cubed. So sometimes you'll have to do a little bit of maths before you can identify that actually the last term is like with the first term. So we have 10z cubed minus 6z cubed, that's 4z cubed, minus 2y squared plus 4x squared. And this is the solution. So this is how you identify like terms and how you group them together.